Hello everyone, and welcome to the smoothon Making Things with Milo live presentation on brush-on molds. My name is Milo, and I'm your host today. I'm also one of the material specialists here at smoothon. Now today I'm joined by Jason and Alex.
Hello.
You might hear their voices in the background. They'll be handling the controls and monitoring our chat. Now speaking of the chat, do feel free to use that chat to ask us any questions you may have on today's subject or materials or a particular step that we're working on. Now, we will try to get to all the questions that are posted today, but if we don't get to your personal questions, please feel free to submit a tech ticket using the link in the description below of this video. One of our technical support specialists is then going to reply to your question in that ticket. Now, what will we learn today here? Today we're going to be learning about when to choose making a brush-on mold versus making a pour-on mold and what criteria that takes basically. Mold making and support shells material options because there's more than just one material that's possible for these projects. We're going to also consider making an intermediate to advanced brush-on mold. So this is a little bit more advanced than a regular brush-on mold would be. Now, we're also going to be dealing with options on how to work with pass-throughs and open spaces between legs or arms. And we're also going to be talking about undercuts and using keys and separation channels, and also just in general talking about using rigid support shells and aluminum shims to make those support shells better and make them fit better together. Now we're going to be working with several materials here today. Number one would be the Rebound 25. That's our main silicone brush-on material that we're going to be using. Also, we're going to be talking about Plasti-Paste 2. That's a rigid support shell plastic that we're going to make the support shell out of. Besides that, we're going to be using the Tyvek silicone thickener, Sonite wax as a release agent, silicone pigment to differentiate the different layers we're putting on, and also Silpoxy in case we have to repair one of our molds. Now, to begin our project here today, we want to start by asking questions. And those questions are going to be asked by you, and they're going to be asked about your project, what you're trying to actually create. So the first questions you should be asking yourself is, what are you trying to achieve with this project? So are you trying to get a metallic finish on your casting? Are you looking for a quarry tone finish on it? Or some other type of finish or material that you're going to be casting into the mold? That's the number one criteria, how you're going to determine what type of molding product you're going to use to achieve that casting. Now, once you determine what kind of material you want for your final pieces to be, that makes it easier to make a choice based on the materials that are available to you. And as you already know, we decided we're going to be making a brush-on mold using the Rebound 25 because we're casting urethane plastics, and I don't have to worry about release agents when I'm casting into it. Besides the Rebound, we're also going to be using the Plasti-Paste 2 for the support shell for our models. All those decisions are made, again, with understanding what we're trying to achieve in this project. If you have a model that's possibly made out of some other material, you might have the option to use a polyurethane rubber as your brush-on mold rubber, or even an epoxy if you're making a rigid mold. You still would be brushing the mold on, but it will be a rigid product. If you're making concrete statues, then you'll go for something else. If you're trying to make wax castings for a lost wax technique to make your pieces in real bronze, all that goes into consideration as far as what materials you're picking. And today we're going to be using the Rebound 25 and the Plasti-Paste. Now, once you kind of determine what materials you want to be using, it goes hand in hand in choosing what type of mold you're going to be making. And the reason why I chose to make a brush-on mold of this particular piece is understanding and knowing what kind of finish I'm trying to achieve and how to achieve that finish the best way possible, how to minimize any air bubble and cleanup efforts in your casting once you demold them. So all that goes into the thought process on choosing the right materials and the type of mold that you're going to be creating. And again, focusing on our model here, the reason why I chose to do a brush-on mold is I wanted to handle this mold by hand, to rotocast into a spin cast material to avoid any kind of air bubbles on the surface. But in general, it would be a huge material savings by doing a brush-on mold on something like this than creating a large block mold that's going to eat up a lot of material. Now, once I decided on the the mold type that we're doing, and we know the materials, we can start by focusing on the model itself. What you want to do is you want to identify difficult areas on your model. What is going to cause us the most problems on this? And in this case, we have these open areas between the arm and the body, and also the legs. This guy. But we also want to focus on undercuts and identify them before you start making the mold, so that you know what to focus on as you're actually creating the mold. So on this piece right here, there's several areas that we want to pay attention to. Behind the ears, there's a spacing that's going to trap air bubbles, and that is considered somewhat of an undercut. The chin area itself is also considered an undercut area, so we're going to have to focus on those. The eyes have deep crevices that need to be filled. The armpits here are quite deep and have deep pockets that receive back, so we're going to make sure we focus on that as well. Back of this hand here has a deep crevice that tucks in quite far, so we want to make sure to fill that with rubber so that we don't mechanically lock our support shell on that area and we can't demold it. So all those areas need to be identified. Study your model in detail. I noticed that on this model, in the bottom here by the pants, there's quite deep crevices that we need to take in account when making the mold. So I'm going to have to focus on that area quite a bit to make sure that I don't trap any air bubbles in there. So once you identify all those areas and you're ready to make your mold, we can start talking about the open spaces. But before I go any further than that, one piece of advice I want to give you guys before you attempt something like this, which is a intermediate to expert level brush-on mold, and you've never done brush-on molds, try something simpler. Try a model that is not as difficult to work with, so that you can actually practice the application of the material on a simple model and then graduate to something that's more difficult and has difficult areas that you have to deal with. It's not rocket science, but it does take a little bit of know-how and knowing and understanding the material to execute this perfectly so that you're satisfied with the outcome and the castings that are going to come out of that. Now, before I start talking more about the model, I'm just going to move these aside because they are in my way a little bit. I like to have a clean working surface, clean working area to produce good work. Now, we're going to start by dealing with these open spaces. The way that I've been taught in the mold making school or knowledge that I have from working at the foundry is that there's different ways to go about this. You can do a glue shim. You can set up your model in clay and then do one side of the mold first and then the other, turn it around. But again, the way that I've been taught is a little bit different. What we did is we created these cutout stencils. This is laminated paper and plastic. So it's not just paper, it's laminated in plastic. It's nice and shiny. The stuff does not stick to it. And the way we did this, we cut out these stencils and then we will insert them here in these open spaces as we apply the first layer of material. That was the basic idea. You create a barrier between the two halves so that you can brush on the material on this side And you can brush it on this side as well. And then when you open your mold, you just remove that card out of it. But in the years since, I've come across this thing called bubble sheets. And I want to show you one of those and what they are. So as I started making more and more molds, I came across these bubble sheets. And basically what they are is a thin sheet of plastic that has bubbles formed into it. So one side you're going to have the positive bubble and the other side is going to be the negative. This is a very thin sheet of plastic, just like the laminated paper that we used to have. So instead of using the laminated paper, I use these plastic bubble sheets that you can purchase online or you can get through our distributors. And what I do is I measure out the original space in my model. I use that as a stencil. Now I come over here with my bubble sheet, place it over, and then trace out the shape of the stencil or shim that I'm trying to create. Once you have that cut out, you're going to have something like this, which is a same shape of the shim that we have here. It's just that this one has an actual key built into it, which is going to be really helpful when we start to cast into our mold, because this area of the mold is going to line up perfectly, creating less of a seam line that we have to actually clean up in the finished mold, or finished casting, rather said. So these come in very handy when doing brush-on molds like this. I strongly suggest having some on hand. Now, once you actually measure those out and you have the spaces filled, you want to keep in mind that we're just creating the shim so it barely fits into the area. You don't want it scraping against the model hard. You just want it to be barely sitting in there and barely holding on. And there's a reason for that as well, of course. Before we get into placing those into our model, let's just talk a little bit about your working surface. So here I have my rotational table. I set something like this up every time I work on a mold, just so I can work on my piece from all angles without actually having to move around the entire work area. So really good to have a rotational table like this, but that's not what we're going to be working on. Our work surface is a separate board. And here I'm using a melamine board, but you can use all kinds of boards that are non-porous and your material won't stick to it. Otherwise, you have to think about sealing them and so on. So here I'm using a melamine board. I secured my model onto the board using some hot melt glue. Very basic, because this is a light model, it's not heavy. I don't have to worry about it coming loose. It's staying on there just fine. If you are working with heavy models or bigger models, it's a good practice to put a hole through the working surface and attach it firmly, so that you don't experience any kind of model delamination from your working surface while you're trying to make the mold or the support shell. So really important to have that be nice and sturdy on your working surface. Now, once we have that applied to the working surface, we're actually ready to apply the first layer of rubber. And again, we're going to be working with Rebound 25 today. I'm going to mix some material up for you guys and show you how I apply that. Now, let's just review the Rebound 25 quickly.
Hey, Milo, before you go there.
Yes, sir.
Someone is asking where to get those bubble sheets from.
Okay, so we got a question online asking where we get these bubble sheets from. And I get a little spoiled here because we have a distributor in the building. Reynolds Advanced Materials is actually in the basement here of the building. Lobby. They have these sheets. Reynolds Advanced Materials has them, and I get them through our distributor. They are available on other sites online. I'm sure you can find them, but for me it's really convenient to go through my distributor and get them there. And they're also have different sizes on them depending on what size the model is that you're working on, which is really nice. Good question there. So we're working on our rubber, our first layer with the Rebound 25. And if you're not familiar with the material, make sure that you read up on it. There's a technical bulletin that comes with the material. It's going to have a lot of information as far as what's the mix ratio, what's the working time on the material, what's the cure time. It's going to have very useful information that you should be aware about before you actually start working with the material. Now, this is a 1-to-1 mix ratio by volume, so it's easy to dispense and start mixing these together. And the one thing you're going to hear me say over and over again is scrape the sides, scrape the bottom of your mixing container. Scrape the bottom, scrape the sides, and mix. Keep in mind, it's not really about how long you mix the material for, even though you want to keep the working time in mind, but how thoroughly, how well do you mix? So even though I did all this mixing here, I know that there's a groove at the bottom of my mixing container here. And if I don't get that material mixed well, that is going to end up in the first layer of the mold. So make sure you get into those grooves, and then to make absolutely sure that this material is thoroughly mixed, we do something called a double mix technique. Once you mix the material, it is then transferred into a secondary clean mixing container. Now, everything that was in the bottom of my mixing container now ends up on top, and we're going to mix it one more time, scraping the sides, scraping the bottom of the mixing container. Now, I did not mix up a lot of material here, and there's of course a reason for that. On the first layer of your brush-on mold, you're not focusing on applying a lot of material to the model. What you're focusing on is applying a thin layer, or what they call a print coat or beauty coat, to the entire surface to capture the detail that's in your sculpt. So now that we have our material mixed, we can start by applying some material to our model. And for that, I'm using a chip brush where the bristles have been trimmed down, so this is nice and hard. The bristles are hard compared to a regular chip brush where the bristles will be soft. And the reason for that is you want to make sure to push in the material onto your model. So we can start by applying some rubber, and this is called a stipple technique. You're basically pushing the material into the detail of your model. Now, this is really good when you have a rigid model made out of plastic to work with, but 9 times out of 10, the models that we received at the foundry to work on were actually made out of clay, which made the stippling technique not the right approach. So what we did is we would apply the material using a soft bristle brush to the model, and then use some compressed air to blow that material into the detail of the model. So it's a question that I get fairly often about what to do if your model is made out of clay and you can't do the stipple technique. So use some compressed air. If you do so, make sure that you have a moisture trap built into your compressed air feed line that will remove any kind of moisture that's built up in your compressor. Now, I'm not going to apply the material to the entire model here, but I did want to apply it strategically to this open area between the legs, and I'll show you why. I want to show you how I actually then go ahead and apply those bubble sheet shims that we made. So we have a very thin layer of silicone on here right now, I'm going to take the bubble shim that we created, and we're going to insert it into that opening. Now, it barely touches in several areas. It barely touches the model. And that's where the silicone is going to, you can see right there, it barely scrapes in a couple spots. And that's where the silicone is going to grip onto the bubble shim. See that, where the material is built up? And it's going to hold it in place so we can apply the next layer over the top. So I'm going to proceed by applying the material to the entire model, including underneath the arms, the face. Again, make sure that you actually do a very good job in getting into those details. You have an open mouth or eyes or behind the ears. Any kind of crevice you want to focus on. And then the rest of the material you want to spread down on your working surface. So you're going to work about 2-3 inches off the material around the base. And that's going to become the flange of the mold. That's going to become the basically the side of the opening where we're going to pour the material into. Now, once you apply everything, you have your bubble sheets in the first layer, we're going to allow the material now to actually partially cure before proceeding on to the next step. Now, what's a partial cure? The material, I believe, has a cure time of 6 hours, and a partial cure is achieved before that cure time is up. So a partial cure would be a finger test, right? That would be a good indicator of a partial cure. Now, what's a finger test? Is when you take your gloved finger with your gloves on, and you basically touch the silicone somewhere on the mold where it's not important. You don't want to touch your model, you want to touch it away from the model. So we're going to touch the silicone, and when you pull your finger up, if there's silicone on your finger, that means you're not ready. The material is still fresh and not ready for the next layer. You want to wait till you can touch the silicone and nothing will come off on the glove, but the silicone is still tacky. So that's the finger test that you can do on the layer of silicone you applied. Now I'm going to allow this a partial cure by moving it out of the way. And I'm going to actually move in the next model that I set up for you guys that will look like this. So at this point, we apply the first layer of the silicone, and the first thing you notice that you can actually clearly see the model in underneath the silicone. So we applied a very thin layer. There's no major drooping of the material. There's not a heavy buildup anywhere. You can barely see that the silicone is actually on there. But the one thing you can tell is that these bubble sheets are actually now firmly sitting in the first layer of silicone. Same thing for the ones up above by the arms here. They're as well firmly seated in there. The first layer of silicone is going to hold those in, and they're not going to pop out anymore. So now we're actually ready to apply a second layer. Now for a second layer of silicone, we're going to pigment the silicone itself by using silicone pigment, Silk Pig Blue in this case. And I'm going to add a little bit of that to the silicone. I don't need too much, just a little bit is fine. And we're going to mix that in to one of the parts. And the reason why we're doing this color change in the silicone is so that we can tell clearly where we are applying the next layer. If we just kept the material same color, orange, it would be very difficult for us to differentiate where the material was already applied and where it wasn't. So a little bit of pigment can help you with that. And once you mix the pigment in thoroughly, we can go ahead and combine the A and B together again. And I'm still going to use the same mixing procedure that we did on the first layer. It's going to be a double mix technique.
Hey, Milo.
Yes, sir. We got
Someone
another
is
question.
asking about if they wait a full day before they put their next layer on. Is that all right?
Okay, so we have a question that came in. Is it okay to wait a whole day before applying the next layer? It is not really recommended. When you start a brush-on mold like this, you actually want to get it done before the first layer fully cures. So before the 6 hours is out, you want to finish it and leave it alone so it can fully cure. Now, in my past, I've learned that that's not always possible. There's going to be times where you're going to be pulled one side or another. You have to go run do this, you got to run do that, and your mold is going to have to take a second seat. What happens then is that dust settles on your silicone and the possibility of delamination is even greater. So what we did in the foundry is to come back and clean the entire surface with isopropyl alcohol. We will brush it down with isopropyl alcohol, leave that alone for 20 minutes to dry, and then come back when it's dry and apply the next layer. Usually we didn't have issues with that. However, the possibility for delamination is still there. I'll give you an extreme example. I was giving a mold that was started a year prior. 2-3 layers were applied, and the mold was left sitting for about a year. When it came to me, no matter how much I cleaned the mold, I couldn't get the next layer to stick. It just delaminated. And what I ended up doing is I took fine sanding paper and took it to the previous layer of the rubber, cleaned it up thoroughly twice using isopropyl alcohol, and then went back to it and applied another layer, and that actually stuck. So that was a very extreme case, but in most cases you want to get the silicone application all done within 1 day in that time period that the material cures in. So now that we have our second layer mixed up, again, we added a little bit of Silk Pig Blue to differentiate the colors here. And then I can start by applying the material to our model. Now, the one area on this model that doesn't have any silicone is the shims here that we put in. So I'm going to start by removing the plastic off the brush. That was silly. I'm going to start there, and I'm going to start applying some material right over that plastic shim. You want to make sure to build up a layer over everything. Inside that key, even though it's a deep, big key, we still want to apply a single layer of silicone. And I'm going to continue this, brushing it over all the surfaces until I cover the entire model. It's really important to pay attention to those deep crevices and undercuts, like we talked about here last time, earlier. This under here really needs to be paid attention to, so we want to shove material in there to make sure that it gets a layer of silicone. Again, keep in mind those difficult areas that we identified earlier and focus on those to make sure that we don't trap any air bubbles in the next layer. And then we're going to spin this around and come back to the other side and do the same thing. So we want to make sure apply a layer of rubber over the entire shim that we put in the first layer. And you remember those open areas that still have some space in between? Now a layer of rubber is going over those and partially closing them as well. If we don't get them closed this time, we'll get it on the next round. So again, you want to cover everything with the second layer, and here it becomes very clear why that color change is really important and helps you out quite a bit. Now, keeping the working time in mind of this product, if you can't work on the entire piece You can't use up the material that you mixed on the entire piece. Work on smaller batches and apply the material in a couple of shots instead of over the entire thing. Because the last thing you want to do is have the material start to set up while you're applying it. And just like in the first layer, we're going to bring that flange around our model out to about 2-3 inches away.
Hey Milo,
Yes.
you can do multi-durometer or multi-speed silicones as long as they're the same type of silicone. So for example, if you did rebound 25, for the first 2 layers, you could use rebound 40 for layers from then on, or even maybe if you wanted to use thickened dragon skin or something like that. Yeah.
So the question we had coming in is it okay to use different durometer silicone for the first 2 layers and then something else for the other 2, 3, 4 layers? It is possible, it's fine. What you want to keep in mind is that the chemistry of the materials you're using is same. So if you're using platinum silicones, then you have to stick to platinum silicones. If you're using tin-based silicone, stick to tin-based silicones. I've seen and heard of customers applying 2 thin layers of dragon skin first, nice soft material, and then backing it up with something like rebound 40. So that's absolutely possible and doable. You just want to, again, keep in mind the chemistry behind the material, and also keep in mind the working time, because these materials all have different working times. So while this one will partially set up in about 40 minutes, another one may not, and you want to be aware of that as you're working with the different materials. Also keep the mix ratios in mind as well. So a lot of information to keep in mind as you're working on these. And again, I'm not going to apply the material over the whole thing, just wanted you guys to see what it should look like as you're applying the material. And again, this rotational table here comes in very handy. Now, this is allowed a partial cure for about 40 minutes before proceeding on to the next step. But no worries, I actually set up the next step for you guys so you can see it in 2 seconds. Now, keep the questions coming. It's very informative. I hope to answer most of them to help you guys out to understand this process much better. So this is after the second layer. We have covered the entire model with the second layer. You can tell it's blue. One thing that you're going to notice is we have some drips that developed. We have some drips on the chin here. We also have some drips on the hands. You can see that. You can see the one on top here. And then if you look over the model, there might be some more. I know there's some right here. There's a couple small ones down here. And you want to make sure that you actually get rid of those before proceeding on to the next step. Those kind of drips will help to trap air bubbles in the thickened layer. So we want to get rid of them carefully. You know, snip them off with some scissors. And you want to be careful not to cut to the actual first layer that you build up. And we're going to come back and cut some more. All right. And once you have them all removed, there's a couple of things to start thinking about for this next layer. Now, when I first started planning this mold, I already decided that I'm going to cut half of this mold up to the top of the head. We're going to peel that mold open then to retrieve our casting out of it. Now, because we're making a cut to the top of the head, that cut area is going to be one of the weakest points in the mold, because we're going to constantly be pulling and tearing, pulling it, stretching it, and possibly tearing it. You could easily put a tear into a silicone where you already have a cut that was started. To prevent that from happening in a mold like this, we're going to use some reinforcement cloth or power mesh. There's a couple of different names people use for these. This is a mesh-like cloth. And one thing you want to be aware of about these is that they're not all equally stretchable. So this one is nice and stretchable. it actually stretches evenly in all directions. So that's something to keep in mind, because some of them, like this one here, this one actually does not stretch as much in all directions. It stretches more in one and not at all in the other direction. And while these are available in many different sizes and different manufacturers, you want to be aware of what it is that you're using. So not every mesh is equal or even. And you can get these as well from our distributors. If you visit our distributors, give them a call and check if they have them in stock. And they should be able to supply you with those. We're gonna take a little bit of that mesh and we're gonna actually cut it to a smaller size that's gonna fit on top of our statue's head here. So take this now and place it over the head. Again, this is where we're gonna cut the mold up to. So we want to have extra reinforcement for that cut area. Again, planning ahead is a very, very big step about making brush-on molds. You want to think 2-3 steps ahead and understand where you're trying to go with the entire piece. Now, this layer is called layer 2.5, and the reason why it's called layer 2.5 is we're not applying the material over the entire mold. We're only going to apply it to undercuts, deep undercuts, and difficult areas. And for that, we're going to have to thicken up the material using the Thickened. Again, this is a thixotropic agent for thickening. It works on platinum as well as tin silicones. This is a smaller bottle that I like to use. It's available also in larger quantities. But the way it works is that we're going to combine our A and B together, and then we're going to mix it thoroughly and then add some Thickened to thicken the rubber. I'm always going to follow the same mixing procedure. Scrape the sides, scrape the bottom of your mixing container, and then follow up with a double mix by transferring it into a secondary container. While the Rebound 25 is a brush-on material and actually somewhat thickened for the application, it's still a little bit too liquid to build up large thicknesses of material onto your mold. So that's why we use the thickener called Thickened. Again, once you mix your material thoroughly, scrape the sides, scrape the bottom. We're going to transfer it into our secondary clean mixing container. And then we're going to mix it one more time. Again, it's a very inexpensive way to assure that you mix your material thoroughly and you won't have any kind of unmixed material that ends up on your mold. Now, I just want you guys to see this. Once this is mixed, you see the viscosity? It's thick, but it droops off. You can actually pour it if you want to. It does not stay on the mixing stick. Now we're going to add some Thickened, and you're going to add this based on the quantity of silicone that you're mixing. For a small batch like this, probably 15-20 drops is fine. The more material you have, the more thickener you're going to need. But the neat part is once you mix this in, you're going to be able to immediately tell how thick the material is. So the tip here is that you don't want the material to be too runny. You want it to be just thick enough that it doesn't slump. That's still a little bit runny. But you can add the Thickened in small quantities to your mix. So you don't have to add a lot in one shot. You can actually overload it. So smaller quantities and ease into it. Of course, always keeping in mind the working time of the material, because you don't want the material to set up in your mixing container. Once we have the material mixed in and we're happy with the consistency, and see how thick that is. It doesn't move off the mixing stick compared to earlier where it just drooped off. This is the right consistency that I want to work with.
Hey Milo, how do you decide how much material you're going to use per batch? I'm assuming you're just doing small batches because if you need more, you can mix more up.
Right, so the question is, how do you determine how much material you need per batch? And that's really up to you. You need to scale it based on the first layer that you did, which is the smallest quantity, and then you're going to slowly step up from that and increase the material. Because every time you add material over existing silicone, it's going to grip on to the previous layer, and your application, your layer is going to be just a little thicker than the previous one. You can always mix additional batches if you find that you don't have enough. And I'd rather do that. I'd rather mix an extra batch than mix a lot of material that I have to discard then after if I'm not using it. So sometimes smaller batches actually work to your benefit, especially if you're working on large molds. This is actually, I would consider this rather a small piece. If you're working on something that's really big, then your batches are automatically not only going to be larger, but you're still not going to be able to cover the entire piece with one batch. I hope that clarifies that. It's a little bit kind of left up to you to fine-tune the quantities of materials that you're going to be using. But again, a little bit smaller, a little bit less is better, because you can always go back and add more material. That's the beauty of brush-on molds. So our material is nice and thick. We can start applying it. And now I'm going to focus on several areas. I'm going to focus on those undercuts we had, on the bubble sheets, the deep crevices of the bubble sheets, and I'm going to focus on the eyes, behind the ears, the mouth, and the armpits. Basically, anywhere there is a deep crevice, I'm going to focus on. And I just noticed I didn't cut one of the boogers off, one of the drips. I'll cut that off. And then we're going to start applying the material. Here I'm using a mixing stick, just because I like the size, I like the actual shape of it. I also use butter knives or any kind of tool that I find is going to help me with the application of the material. Now, one key here to remember is once you start filling those undercuts, you want to push the air away from your model. So you're squeezing, you're pushing the material in kind of steps, and making sure you're pushing the material into the crevice and the air away from it. Keep in mind, we're not trying to fill all these deep undercuts on one go. And the reason for that is that thickened material tends to trap air bubbles much easier. So we rather do 2 applications than one thick one. So that's how you start using the thickened rubber. And then you're going to basically make your way around to all the difficult areas on your model. So I showed you how to fill that. I'm going to start by working on the eyes as well here. Remember, you're pushing the material into the crevices and the air out and away.
It's a good point. Somebody's mentioning Thivex, and when you use too much Thivex, you actually can get inhibition. So you want to stay within the max, which I think might even be 2% if I'm not mistaken.
So we have a comment that came in online saying that you have to be careful when using Thivex because you can actually overload the material and not have it cure. That is absolutely correct. That's why I like the idea of stepping up and into the thickness that you need rather than applying a lot in one shot. I actually had that horror experience where I added too much material to silicone, too much Thivex, and it never wanted to set up. So again, the stepping into the thickened material is much better than adding a lot. You saw me, I didn't just squeeze the bottle and just kind of have a stream going of the Tyvek in there. No, I added in a couple of drops. I did 10 drops the first time and then another 10 the second time. So absolutely correct. You want to be aware of those little things. Just like you can add too much pigment to the silicone and inhibit it that way. So there you have it. I filled in the behind the ears, the eyes themselves, and we're going to add a little bit to the underneath the chin area. And you can see I'm not adding it directly, I'm adding it from the side and pushing the material into the place so that it pushes any air bubbles away from our model. Again, this layer is not really meant to be applied over the entire piece. It's just focusing on the thickened areas where we need to add thickness. Now, one thing I want to really point out here is, I want to see if we can show you guys this. Here, back here in the armpit crevice, there was a little hole that wasn't filled in the first 2 layers. By squeezing the material now on this side, we were able to fill that hole, and the material came shooting out on the other side, now filling that area. So really important to pay attention to little things like that. Now I can come back and fill that area from the other side. Again, being very careful and pushing the material into the place while trying to push any air away from it. Again, this is not really difficult. It just takes a lot of attention and it takes some skill. I would be lying to you if I said I never made a mold that didn't have any air bubbles entrapped. It happens. We're not perfect, but we try to be. So the more attention you pay to this right now, the better your mold will come out. And of course, out of the better mold, we're going to produce better castings. Again, you don't have to fill this on the first go. You're just starting the filling process. There's going to be another time where we're going to come back and fill them completely so that they don't create any kind of undercuts where support shell can mechanically lock in and won't release from. I want to do one more thing here and show you how I fill this bubble here on the bottom, because that is a large area to be filled. So start at a corner and press it, and then use that material on the side of the leg as well. And this is a really good example when you want to mix smaller batches, because it just takes a little bit more to apply this. It takes more time to apply this, so working in a smaller batch will be very beneficial here. And once I make my way around all the difficult areas, I'm going to come back and focus on top of the head here. We're going to apply some material to the head. This doesn't have to be really a lot of material here. This is just going to be used as adhesion. Remember, we're going to embed that reinforcement cloth on top of the head. So once I have some material down, fill that behind the ear.
Now here's an interesting point, is a mold like this, a brush-on mold you're making with thickened material and multiple layers, wouldn't really be suitable for pressure casting because there may be some bubbles in these thicker layers away from the surface.
Right, so the question we got is, a brush-on mold like this would not be suitable for pressure casting. And you are absolutely correct. Again, think about my criteria that why I picked making a mold like this in the beginning. I knew that I was going to rotationally cast the first 2 layers to get rid of the surface bubbles and then backfill it with more material. So I knew going into this that this is not going to be a pressure casting technique, just because I identified the difficult areas and no matter which way, I would have had to add air vents to it, which again is going to add detail to my model. So I wanted to stay away from that, and that's why I went with a mold like this, understanding I'm going to be rotationally casting into it at least 2 layers and backfilling it. So that decision was made long ago, and we're right here, and we're already committed to that process. If you wanted to make a pressurized mold where you're actually going to pressure cast into, then maybe a block mold would be a more appropriate for something like this. The pros for a block mold like that is that you can do it really fast. You pour the material and you walk away from your piece and you put it in the pressure pot, and now you can use it for pressurized casting. The downturn to that is that it's going to eat up probably 10 times as much material as a brush-on mold would that is applied this way.
You could also do, not to interrupt, you could also do a like a cavity pour mold or a matrix mold if you wanted to use vacuumed material.
So another choice Jason mentioned that, again, you might not think about immediately, but he's absolutely correct. You might decide to make a cavity pour mold where you can still make a fairly thin mold of your original object, but you can actually pressurize the mold itself. Now, a mold like that will definitely eat more material than a brush-on mold would, for sure. But again, it's a solution to a problem that you're trying to solve. So, you know, I would have made that, again, that decision would have been made early on about how we go about making the mold for this. So now that we're applied, we filled in our undercuts with the first thickened layer. We applied our reinforcement cloth to the head. We're going to allow this a partial cure before moving on to the next step. So I'm going to get this out of the way, you guys. And your model now should look something like this. So we filled in all the undercut areas that we worried about. We filled in around the chin, the face. We applied the reinforcement cloth on top of the head. We applied the leftover material to the flange around the bottom here. But you can see that we clearly did not apply a full layer of material over the entire model. And that's what we're going to do now. Now is the thickened layer. This is layer number 3 that we're going to thick up the rubber with some Thickened again. And I'm going to show you that as well. Now, on this next layer, I'm not really going to be doing a color change, and the reason for that is that I actually want to see where I'm applying more material to the blue underlaying versus applying it to the area that I thickened up in the previous layer. So just like on the first thickened layer, we're going to mix the A and B thoroughly together. Scrape the sides, scrape the bottom, do a double mix. And then we're going to add the Thickened to it. And just like previously, I'm going to add Thickened in at least 2 steps. I'm going to add some and then see how thick the material is. And then add some more. Scrape the sides, scrape the bottom, and then transfer into another clean mixing container. Now, one thing I forgot to mention, you guys, and just occurred to me, is that we did not pour our aluminum shims, our separation keys. I'm going to pour that next to show you guys. I should have done that actually on the last step, but we skipped over that because I wasn't thinking or overthinking it. So now we're going to add some Thickened to this again. couple of drops to begin with, 10. We're going to mix that in. As always, keep the working time in mind of the material. Now, again, you check your viscosity. This is a little bit too thin for my liking, so I'm going to add a little bit more. Mixing stick wants to go somewhere. And that's the beauty of using this Thickened thickener, is that you can tell pretty much immediately how much thicker that rubber is going to be. So there we have it. Again, it's nice thickness, nice consistency, and I'm actually ready to apply it to the model. Now, you can use a chip brush, or you can use a mixing stick or some kind of tool to apply the material on there. The idea here is that you're applying now a thickened layer of rubber pretty much over the entire piece, but again, I like to focus on the areas where I haven't applied on the last layer. So anywhere I see blue, I'm going to apply extra material there, just because it's not as thick as everywhere else. Now, I'm going to show you that I also do use brushes on these things. And when I am applying the material, I'm trying to not create too many jagged surfaces. Not too many jagged. You don't want to apply it and have it look like that. You want to have nice, soft surfaces. And you want to try to apply it as evenly, as equally as possible as far as the thickness. And I'm just going to continue this until the entire model is covered up. Now, if you have finished applying this thickened layer over the entire piece and you just don't feel like you have enough thickness on your mold, now is the time to add additional layers. So let this partially cure, change the color, and then add another layer. Again, if you're working on large molds, you want the rubber to be just a little bit thicker than if you're going to work on tabletop size pieces that are quite small. Keep in mind, the thicker the rubber is on your mold, the less maneuverability it's going to have, the less stretch it's going to have, the harder it's going to feel. The thinner it is, the more flexible it's going to be. Now, we're going to move this aside and let it partially cure. And in the meantime, I want to show you guys how I create separation lines, separation keys, and keys for my molds in general. I'm going to move this aside. And I'm going to show you some of those keys that I mean. So this is a aluminum channel, very basic piece, hardware. I'll remove my clay that I put in there so you guys can see it's a U shape. And that's what we're going to pour the silicone into to create our separation channel. Now, these come in different shapes and sizes. So based on the size of your mold you're working with, you might want to choose one or the other. I'm simply going to plug it up with some Sculptic Soft clay. This is an oil-based clay that won't inhibit the cure of my material. But one thing I want to show you guys is this right here. If we can zoom on that, please. Platinum. Now, why did I write platinum on that? This tool, this aluminum channel, is only used for making platinum silicone castings. I don't want to cast anything else in there that's going to inhibit the cure of silicones that I might be using down the line. So keep those little things in mind when you're making these. Now, these keys come in different shapes and sizes that you can make. These are different keys that I made using different containers. These are little syrup cups, ice cube trays, ketchup cups, and you can see that they're different thicknesses, also different hardnesses based on the mold that I'm using and making. Some of them have embedded mash reinforcement cloth in them, so they're adhere much better to the mold and hold on much better. But what we're doing here is we're going to create we're going to create this silicone separation key using this aluminum channel. I'm going to go ahead and mix up some material so you guys can see how that looks. The mixing procedure of my silicone always stays the same. Always scraping the sides, always scraping the bottom of the mixing container. No thickener is added to this step here. We want to make sure that the silicone flows nicely into that channel. And once you start making keys like this and separation channels out of these molds, you're also going to learn how much material a channel like this will take. You'll know how much rubber you're going to need to mix up for that channel. When I used to work in the foundry and we poured the channel, we would accommodate the amount of rubber we're mixing for the step to pour the channel and apply the next layer to our rubber mold. So if you're doing stuff like that, you just want to be accommodating with the quantities of materials that you're dispensing. And that goes into the question we answered earlier: how do you know how much material to mix up for a specific layer? You want to take in consideration things like this, steps like this. You want to take in consideration the flange you're building up. All that goes into decision making when you're dispensing these products. Scrape the sides, scrape the bottom. Did I mention that already? All right, so once you have your material mixed, we can pour it into the channel itself. I'm just going to start at one side. And this does take a little bit of practice to have nice quiet hands. If you do end up spilling anything over the edge, don't worry about it, just leave it.
Milo, you didn't have to put a release agent in this, correct? Because it's aluminum, it'll peel right out.
So
okay.
One question just came in. We didn't put any release agent in this. That is absolutely correct. The nice part about silicones is that they release from a lot of different substrates, including aluminum. So no release agent is necessary here. The other thing is, if you are adding a release agent at this step, you're going to have that release present on your casting, on your channel. And now if you're trying to adhere that channel onto the rest of your mold, that might become quite impossible. You're going to have some kind of delamination issue, and you want to avoid that. And you can come back if you missed a spot, or if you just need more. And one thing to keep in mind, I only create these channels when I need them. I only create them for the mold that I'm working on. I don't make 10 of these and have them hanging out and waiting for a project. You want to make them with the material that you're using on that specific mold when you need it. And that's how I pour my separation keys and channels, and these are then cut up in smaller pieces when it sets up. So this is now moved to the side and allowed a partial cure before we end up using it in one of the next steps. Move that aside. Is there any questions about the keys that we're making here, the channel that we poured, or about the last layer that we applied?
Not really. I mean, the key there is to make sure you're using the same type of silicone as you're making your mold out of, so you don't run into any inhibition issues.
All right, so clean up our workspace. All right, so that is allowed to partially cure. We're going to move on to the next step, which we already set up. And here is our model with already partially set up thickened layer over everything. I already prepared some channels, keys here, but what it's going to look like when you actually get these cured, you're gonna get your channel, and then we're gonna peel it out. And there it is. So you have your square profile that you're now gonna use as a separation channel where the two parts of the support shell are going to meet and separate. So I just want to show you guys what I mean by that. We're simply going to use this now and build it over the edge where we're planning to separate the two halves of our mold, or sorry, the two halves of our support shell. So this is going to be cut up and adhered to the side of our mold. So, and to do that, we're going to use a razor knife. Grab one of my knives here. And what we're basically going to do is we're going to cut the sections that we're going to adhere to our mold. It's very difficult to adhere something that's bouncy and reboundy. Is that even a word? You're going to have a tough time trying to adhere this into the crevices. So it's much easier to cut these into smaller pieces and then work them in there using some thickened rubber and pins, sewing pins. So again, we're going to show you how I go about these. We're going to start by cutting them in sections, starting at the foot. And I'm actually cutting these according to the shape that I'm trying to fit. So you can see here, this is cut at an angle, and that's to fit this angle here in the rubber. So this is where that's going to meet. I'm just going to continue up the side. One thing I forgot to mention that's really important here, these channels do have two sides. There's a side that you poured from, and there's a side that was in the mold. The side that's in the mold is nice and clean edges, whereby the side where you poured from is not as perfect. That's the side that we're gluing down onto our mold, right? So that the clean edge is going to point up into our support shell. Now, once you actually cut all these to size, you're going to adhere them using some thickened rubber and some sewing pins. I'm going to put just some of these on here. A really good tool to have in your toolbox. And we're going to mix up a little bit of rubber. So one thing that is becoming more and more obvious is how much more time-consuming a brush-on mold is. And it's something that you should take in consideration when you're making this decision. But on the other side, it's going to save a lot of material versus a block mold or even a cavity pour mold, which is going to use 3-4 times as much as rubber. So those are the decisions that you have to make early on in the process as you're making your mold decisions. Now, this material here that I'm mixing up this batch is again going to be thickened. And once we mix the material, I transfer it into a secondary mixing container. And it's really up to you now if you want to add any pigment to it. You can, you don't have to, but keep in mind it's up to you to apply the material. So anything that can help you visually to do so, I strongly encourage on doing. Any kind of help is welcomed. So once that is mixed, add a little bit of Thivix again. And then mix it in thoroughly to get that thickened consistency in our material. Again, you're going to see how thick that is. It doesn't move off the mixing stick. It stays firmly on there. Now what you do is you're going to take some of that mixed rubber, the thickened rubber, and you're going to apply it to the back of that key that you cut. Just like that. Apply it to the back, and then we're going to use the same material and apply it where you're going to apply that key. And this doesn't have to be very pretty at this point. You're just going to put some material down, and then we're going to squeeze that into the rubber. A couple of pins now will hold it firmly in place. Now, you may not need pins on a piece that's flat on the surface like this, but when you start working up the side of a mold, you're definitely going to need pins. And what you want to do, once you apply the material, you want to come back and smooth it out away from your separation key that you just built in there. You want that edge of the separation key to be as clean as possible, because that's where the support shell is going to register onto the mold. And the cleaner those surfaces are, the tighter, cleaner fit you're going to get from your support shell. And that's how you apply your separation channel onto your piece. Now, I'm also going to apply some keys around the perimeter here, and that's going to hold the flange of the mold in the support shell as well. Same procedure. You're going to apply some material to your back of the key, and then to the surface itself. Squeeze it in there. Again, you don't really need the pins in the flat pieces. I'm just going to pull some of that material away. And if I can get a front view on this key here, please. There's something I want to point out to you guys. You see how this key is not just cut flat. It has actually a V shape to it. Both sides have a V-shaped groove that's cut into them. And that's basically going to hold the rubber into the support shell itself, those keys, and prevent them from moving out and popping out easily.
Here's a question.
Yes.
If you have these keys, obviously you want to make them fresh when you use them.
Yes.
So you have, good lamination. If you have older keys, there's really no way to encapsulate them with anything that'll help it stick any better. Will it?
So the question is, if you have older keys from your previous mold that you made, is there a way to save them and continue using them on your next mold, or you really have to make fresh keys every time you make a mold? The answer is somewhere in between. The best procedure, the best practice is to make fresh keys for that mold. However, I've personally been stuck here or there with a mold where I just didn't have enough of the separation line, but I had some left over from the last mold. So what I do is I take the key that I have made already, and I will wipe it down with isopropyl alcohol. You want to clean it as good as you can, possibly even 2 or 3 times. You want to remove any dirt that's collected on there. If you guys worked with silicone, you know that they attract dust and dirt very easily, so you want to remove any off of those keys before you go to use them. Same thing as if you were applying the next layer after this mold has been sitting for a day or so. So same kind of procedure would apply. And I'll show you guys also in the next couple of steps how we finish those keys to make sure they're thoroughly embedded in our setup here. I'm just going to move this step aside, and just like the previous step, we're going to allow it a partial cure before moving on to the next step. And here's what your finished piece should look like. If you guys want to take a second to study that a little bit, you're going to see that I put pins all over the entire piece when I apply the channels. But more importantly, if you look right here on top of the head, you see these little pizza slices that are added into the separation shim. Basically, to form this rubber piece better onto the head, I cut little slices, just cut into the rubber, put it onto my piece, onto the mold, pin it in, and then fill these with a little bit of the extra silicone that we have that was thickened up. So that makes the rubber hug the model much better. Instead of having square shapes and hard to maneuver rubber, we have a much better, tighter fitting rubber piece that goes over the model. And you can see that over the entire piece, so I'm walking here, any of the leftover material I had that was thickened that I used on the separation channel buildup, adhesion, I actually then went on and brushed on over the rest of the model, not to waste it, right? Why would you waste material? You can just take it from the edges and just push it onto the model itself. Now you can see the keys on the bottom now held in firmly, nice and firm. Can't get those off easily. And now the next step will actually encase the entire piece in a layer of rubber, so that kind of encases everything we applied, especially the keys, which were the last ones to be applied. It basically bonds them even better to the previous layers. So to start, what you want to do is you're going to pull out all your pins that you put into the silicone. Put those aside, and just like that platinum channel that we have, these are only used on platinum silicones, and I keep them separate so I don't inhibit any material cure. Now, once you remove all the pins, which I'm not going to do, it just takes too long, I'm going to take a razor knife, and I'm going to basically trim the rubber flange around our model. Once we do that, we're going to put some cuts into the separation channel so that you can actually put the aluminum shims in it, but that will come next step actually. So let's go ahead and just start trimming our rubber away from the model. I'll cut all that extra material off, and I'm staying within probably about 1 inch of those keys. So once you peel this away, you're going to have a nice clean edge around your piece. And you can also identify how thick your rubber mold is at that point. This is kind of the approximate thickness that you're going to have to the entire buildup. So it looks pretty good to me. I'm happy with that. Now, once we go ahead and remove all the pins, we trim the rubber back. There's one more final layer, like I said, that gets applied over the entire piece. I'm just going to move this out of the way. Looks like we forgot to trim the bottom here, so we're going to do that here as well. So our next step here is basically finishing this mold. And once the final layer has been applied, your mold should be nice and smooth. This final layer is actually not thickened. You just apply the rubber over the entire piece, and let it smooth out some of those sharp edges and sharply build up silicone.
An interesting point about these keys is if you're working on something really huge,
Yes.
you may end up having to put some keys on the actual figure
Right.
to keep it from flopping into the mold, into
Right.
the support shell.
So the comment we just got is if you work on a larger model where the span between the one side of the keys, a separation channel to the other, this area here is so large that the possibility of the mold flopping inwards is great. And again, it's something that you want to think about way before you start making the mold. That does happen, and you want to know how to counteract it, how to fix something like that. And I'll show you a mold here in the background that is larger where I've actually done that. Basically, what's going to happen is you're going to have to apply keys onto your actual mold center. And this is a huge key, of course. This is way too big for this model. But you want to put them somewhere in the center so that the key in the center is going to adhere to the support shell that's going to hold the key in place, like that, so that the rubber inside can't flop in and out. It's going to be held in by the support shell. If you look sideways, that's how it's going to be held in. Again, I will show you a good example of that I have right behind my left shoulder here. But one thing that I frequently get asked is, let's say you do have to apply keys like that over a large area on your mold. How do you determine the size or the span between one key to another? And a basic technique that I've been taught is to use your pinky and your thumb. This is approximately the area that you want the spacing from your edge of your mold to the next key, and from that key to the next key. So that's approximately about 10 inches plus minus that you want to space those keys out. Now that will also depend on what type of mold rubber you're using, how thick or stiff the rubber is. So all that has to go into the calculation as far as do you need keys like that and where you're going to apply them. Now I'm just going to quickly finish trimming some of this. So this is almost ready now for our support shell. Now the way that we're going to build up the support shell onto this is going to be by cutting a channel into the separation line here. And then we're going to embed, we're going to push in separation shims. And those separation shims are going to be made out of aluminum. Again, this is something that I've been taught how to go about these. There's many different ways, many different materials. I know that some people use playing cards to do these kinds of shims where they separate them. I personally use this aluminum flashing. This is very thin stock. It's not very thick. It's easy to maneuver, easy to bend over. And I actually use this for mold walls as well. There's many uses for this type of material in your toolbox. But I'm going to quickly show you how I make keys and shims for our separation line here. You're basically starting by cutting a shallow cut into the entire separation line here. And that cut is going to determine how far you stick these shims into the rubber. So I take my razor knife here, and I'm going to push the blade out until it's about 5 millimeters. You see that? It's hard to tell. Can we zoom in on that? So you can see how far that blade is sticking out. Not very far. That's about 5 millimeters. And that's where I'm going to cut into the separation channel. Not more than that. If you go any deeper than that, you're actually running the possibility of cutting into the mold, and we want to avoid that at any cost. So once you had your knife set, we're going to start here at the top of the head, and then we're going to cut slowly. You want to make sure that you keep your knife centered in the middle of the separation line. And you're going to follow this basically all the way around the separation line that you build up. Sometimes it takes some steady hand and going slowly to make sure that you keep that centered as much as possible. And also sometimes you're going to have to come in from the other side at another angle to make sure you actually put that cut in there. Put this out a little bit more. So once you go around the entire piece and you cut a channel, you're going to start by introducing keys for your support shell into that groove. Now, what are keys for your support shell? Basically, they are keys that will help align the two halves of the support shell perfectly, so there's no moving around and registering the entire mold in that support shell quite nicely. Now, here's an example of a key in an aluminum shim that I made. Now, this key is quite large. It's a little bit too big for my mold here. The depth of this key is too large. This might be great on a larger mold. So I'm going to show you guys how I make these and show you how you can control the size itself. So here I got my aluminum stock. Where are my scissors? We're going to cut this. The shim is now folded in half and pressed down. Oh, we got a A shape, a roof. Now we're going to cut into one of the sides. This is the side that is bent over. This is the ridge. And we're going to cut into that. Now, the depth of this cut here, as far as how far in we go, is the depth of the cut that we made on the rubber separation channel. So that's how you control how far these go in. And then when we cut the other way, that's the depth of the key that you're determining. How deep is that key going to be? Again, larger molds, you want to make larger keys. Smaller molds, smaller keys. So I'm just going to cut that out. That's what it should look like. Cut. And then we're going to fold this open. Let's see if we can do that. You know, put your fingers on the sides and press it up. And now you pull that apart, and there's your key. That's the very basic key that you can make for a mold buildup like that. Again, this right here is a perfect size for that size mold. The larger the mold, the larger the keys you're gonna make. Now the keys can go into the separation channel. Here is what I already pre-cut. And you know what? I think I didn't cut that deep enough, so I'm just gonna come back here. Make sure that that doesn't cut too deep. That's quite there. And if you already put a cut in there, you got to be really careful now not to put a second cut. You want to make sure you follow that precisely. Again, don't cut all the way through your mold. All right, now that's deep enough, and we can secure that aluminum shim and the rubber. And that's what it should look like. The side view here, so you can see how that becomes now a key. It's going to have a positive on one side and a negative opening on the other side. And now I'm going to continue this by building. Basically what you do is you put the keys in first on the entire build. You're going to put your keys on opposite sides, going all the way around the model. And one thing to keep in mind that the key itself should be always pointing the same direction. So if one key points in this direction, that direction, see that? Then all of the keys along the entire sculpt should point the same way. You don't want to have one key point that way, one key point that way. You could potentially cause some interlocking and difficulties in demolding your support shell. Now, once you go around the entire piece, keep in mind that these are reusable. You can always, I have a little box of them, reuse for next project that I have. So put those aside. The next step would be to apply some sonite wax to those keys and start our support shell. So your model now should look something like this. The rubber mold is completely finished. We applied our aluminum shims to the entire mold. You can see there what they should look like. So it's a very, very thin aluminum shim that goes in there to create a very thin section that's separating the support shell. Now, before we move on to the next step, which is applying of the plastic paste, you want to put a release agent on the aluminum shims and also on the working surface in case you get some material on there. You don't want it to be stuck and you can't remove it. Put some gloves on. And the aluminum shim, it's not really necessary to put a release agent, but I can tell you that it will come off a lot easier if you do. So I've discovered that just by using a little bit of the sonite wax will prevent the adhesion of the plastic paste to the aluminum shims and make my day much easier when I go to demold the entire support shell buildup. Simply brush it on to the aluminum shim itself. Now, one note that I want to make about the aluminum shims that I've discovered as I use them more and more and more, right here, you can see a little corner there that doesn't match. It's like cut out. And basically what I did is I cut into this shim above and slid the shim from below in so that they actually hold quite tight together. So that's just a little technique that you kind of learn as you're making these over and over again. You can see that. It's a simple cut, and the two are kind of connected to each other just to hold them in place thoroughly so they don't dislodge and just start floating around. Once you apply your sonite wax, you're pretty much ready to go and start applying the plastic paste on our buildup here.
Milo, when you have the shims in there,
yes,
do you have to do anything to the back of them, adhere them with tape, or do anything to help support them?
Right,
all?
so the question is, do we have to adhere the shims with tape in the back or something like that to keep them in place or keep it from moving around? I personally don't. I make sure that they're in there secure tightly, that they lean against each other tightly and nice. Sometimes I will put the shims in, discover that it's not sitting right somewhere, and then I will remove the shim and put it in the back to see if that's going to push one or the other more to create a nice clean seam line. And sometimes it does, sometimes it doesn't. I've seen applications where people put tape, clear tape over it. You can do that. There's nothing that says you can't. Just make sure you apply the tape before you apply the sonite wax, because otherwise it won't stick to it. But yes, absolutely, you can do that. And I have seen it done. Now, for our support shell, we mentioned earlier we're going to be using the Plasti Paste 2. Plasti Paste 2. One thing to keep in mind, this is a 2-to-1 mix ratio material. So again, if you're not familiar with the product, make sure you actually read up the technical bulletin. The last and least thing you can do is look at the label of the material that you're using. It's going to be written on the label at least what the mix ratio is, so you don't get a wrong mix ratio and end up with unmixed or wrongly mixed material that won't cure. And something to keep in mind here is the working time of this product. I believe it's 20 minutes. But most important is to understand that urethane materials do exotherm. So urethane plastics, more specifically, exotherm. And this is a urethane plastic. So once I start mixing the materials and it starts to activate, it generates heat. And you're going to be able to feel that heat on the cup itself as you're holding it. Once you start feeling that heat, that's a good sign that you need to get the material out of your mixing container and onto your model. Otherwise, it could set up quite fast in the mixing container, causing you to lose a lot of unmixed mixed material that ends up costing you money by wasting it. So just like we did before, scrape the sides, scrape the bottom of your mixing container, and while still keeping the work time in mind, we're going to still go ahead and double mix the material in a secondary clean mixing container. You don't want to have any of the unmixed material end up in your support shell. It will weaken the support shell and create soft areas that is not really desirable if you're trying to have a rigid support shell that you have to handle quite a bit. So once the material is mixed, you can start by applying it to your model. Now again, I'm starting to feel the exotherm. It's starting to get a little warmer. Not really warm enough for me to get this out of the mixing container, but I know that it's happening. So the material is mixed well. And one thing that we like to tell you is try to get the material out of your mixing container and onto the model as soon as possible. Now, working on models like this where you have this 90-degree bend here, a lot of material tends to accumulate there, slump there. So what I attempt to do is work in 2 smaller batches and brush the material on. So while I am getting the majority of the material out of my mixing container and onto the working surface, and you can even go ahead now and scrape that off. I'm still coming back with a brush, and I'm going to work that material in a thin layer all over the model. And that includes the aluminum shims. You really want to get in there, especially the keys. Again, spread that material out, get it in the smallest crevices, the little keys, undercuts on the keys. Those are important. And work it all the way to the edge of your mold. Now, you don't want to work over the keys. You want to minimize that as much as possible, avoid it. But the trick that I discovered is it's much easier for me to control the overall thickness of the Plasti Paste by applying it in 2 thinner layers than trying to apply it in one thick layer.
Now the plasti paste will bond to itself really, really well, even when if you put a thin layer on and let it cure,
Yes.
you can go on top of it with another layer. I do multiple thin layers.
Yes.
So that you can really get a good good
so
application.
just like Jason said, you can apply multiple thin layers. It's much easier to work with. It will bond and stick to itself very well. But basically what I'm trying to avoid here is building up a lot of thickened material in an area where it wants to just slump. And I've seen a lot of molds where this area here will be super thick, whereby the edge of your shell will be really thin. So we want to avoid that, and the best way that I found it is to control your thickness by applying multiple thinner layers than one thick layer. Now I can go back and mix up another batch and continue working upwards to complete the entire layer. Again, you want to focus on those crevices on your keys and on the keys on your rubber mold as well down at the bottom. Because those are cut at a V shape, you want to make sure that you get material down in those corners. So once this partially sets up, which is about 10 minutes, I can go ahead and add more material if I want to. I don't like to work on the material while it's still malleable. So if this is soft, I don't like to work more material onto that because it will potentially slump and create really thick areas. So I do give it a partial cure before applying the second layer over the top. Is there any questions about the shims and the application of the plasti paste to our support shell? I'm going to move this out of the way so you guys can actually see what that first half of the support shell should look like. Now, once I apply the material to the piece and it's the final layer, I already built up my thickness that I want, and I apply the last material, I can come back now, and while it's still in its partial cure, and apply some isopropyl alcohol with a chip brush. Let's see if I can get your isopropyl alcohol, you dip your chip brush in, and then you can go around and smooth out that layer of the plasti paste. One thing, if you ever worked with plasti paste, you know that once it's cured, it's quite rigid, and these sharp edges here can cut you quite a bit. So you want to clean the shell as much as possible right off the bat. You can see that I can actually run my hands over this and not worry about cutting myself because I already went ahead and patted this down using some isopropyl alcohol so it doesn't have a jagged, ripped edge. Now, once your first half of the support shell is cured, keep in mind the curing time, 90 minutes for the plasti paste 2. The thinner your application is, the thinner your cross-section of your material is, the longer it will take to efficiently cure where it's not movable. So keep that in mind as you work with the material. Now, we can go ahead and remove the shims from our first half of the support shell. Again, you want to save these so that you can use them again for the next project. Now, the one thing that's I find quite important is now to come back to this build-up area, this nice clean area that you have built up here, and clean it up using some razor knife. Basically what it is, if you look closely here, the back of our key, when we stuck it into the rubber, there's a little area where it creates a uneven section that's right against the rubber. See that? Now that can be potential for locking the second half of the support shell just on those little pieces. Imagine if you have 6 or 7 of those around the mold. That can actually lock the 2 halves of the support shell. So what we want to do is we want to clean that up somewhat so that we have a nicer, cleaner edge. The same thing is repeated on the actual outer edge. And clean some of that extra material off. That looks good. And now what we're going to do is, once again, apply some sonite wax right onto that plasti paste where we remove the shims. So all that gets a layer of the sonite wax. Now we're ready to make a second half of the support shell on this. And I'm going to move this out of the way so you guys can see what that's going to look like. And here's our finished support shell. This is what it should look like once you apply all the material and it's fully cured. Again, I can run my hands on this without the worry about cutting myself because I patted it down when it was still partially cured with some isopropyl. Now we do have this edge here that we do need to clean up. It's still jagged and a little bit covered over the other side. We also need to clean up these keys at the bottom of our support shell, and then we can drill the shell and open it up. At that point, we're also going to remove the mold from the working surface, from the board. And what that piece should look like, just move that aside.
Milo, did you have to put any pry points in this one? Not really.
Sorry?
Any pry points where you're going to pry the mold open?
Right. So a question here that came in, did we put any pry points on this support shell? What is a pry point? I don't know, never heard it. No, a pry point is where you're going to then insert a tool to pry the mold open, the 2 halves. Pry options are really important when you're making epoxy shells or molds, and you're casting silicone into them. That's never going to want to come apart because that silicone is holding on everything. So pry points on your support shell will make it easier to pop those 2 parts open. As you can see here, that's not really required for what I'm doing. So to answer your question, Jason, I did not put any pry points on this particular piece because I don't see the need for it. I've had molds where I did need to have them, and I didn't, which was awful. But in this particular mold, I just don't see the need for them, so I did not use them. Pry points can be very, very, very useful tool to have on a specific mold. I didn't need it here, so no need for applying them. So anyways, let's just jump into the finishing of this. You can see that we cleaned up the edges here. The edge is nice and clean. It's you can see the 2 halves almost. It's starting to separate. And the way that I went about cleaning support shell like this is by using power tools. Now, if you never used a power tool like I do here, which is my favorite tool, 4.5-inch grinder. This thing will take your finger off, no problem. These are dangerous tools. So if you never use something like this, make sure you familiarize yourself with the tool. Have somebody show you how it's used. Watch some videos on it, but don't just start using tools that you're not familiar with. So what I do is I basically chase this entire piece with a grinder like this. You can use a sander, palm sander. You can use a Dremel tool. I just find that this works really fast and clean, and I like to use them. Of course, whenever you are working with power tools and plastics and epoxies, you want to make sure you protect yourself, wear the right respirator. wear glasses so that you protect yourself from the bits and pieces flying off of your mold. Did I mention this is my favorite tool? I did. So once we have everything cleaned up, we drilled holes into it. This is where we're gonna clamp our support shell together. We can now go ahead and actually open the mold. The mold is finished, and we can retrieve our model out of it. One quick note, I did chase the entire surface here a little bit with the sander as well, with the grinder, with the sanding disc, just to give it a nicer, smoother finish. And when you start opening this mold, you want to start at a very visible area. So when I started to clean this mold, this already started to kind of split open where it's supposed to. There's a release agent. So it makes it a lot easier for me. But if you don't have that separation line that you can see, you can always start at the bottom of your mold. But since we already can see this, I'm going to use a tool. It's a painter's tool. Simply stick it in there and give it a slight pry. I'm not really cranking on this, trying to break it open. I'm just simply giving it a breather hold. And next thing you do is, what I like to do is use mixing sticks, tongue depressors, and I'm going to literally just put them as placeholders in there. Why do I use wooden tools like this? They're not sharp. This tool right here will go through the rubber mold inside and cut it and damage it. A wooden tool like this won't, so very easy choice there. However, the reason why I made this choice is because I actually cut a mold with this before, so be smart about the tools that you're using. So now we can just go ahead and follow this seam line, and we're gonna insert tongue depressors in this case, until the mold itself start to give, the support shell start to give and break open. So we're going to do on one side, and then we're going to follow up and do the same thing on the other side. And again, I'm going to start actually up top here. We see the top, because the top has already a crack that developed between the two halves. So it's much easier to work here than where I can't see it. So again, just simply pry it open slowly. You can hear it, a little crack there. And follow that seam line. You can see they're falling out on the other side because it's just becoming open. I think that opened up. Yep, we're good. So I can now remove 1/2 of our support shell from the mold. And really nice visual here. You can see those keys, how they stick out of the support shell, and they're easily identified. This is what's going to help us align the mold back together. There's some more here, here. So that's really important and nice to see. Now we can go ahead and remove the second half of the support shell. Oh, our model is actually getting loose on the working surface. Perfect. Have the working surface? No. A little bit of wrestle now to get the second half off. One thing to keep in mind is that the first time you demold, the mold from the support shell is going to be the toughest time, because there's a lot of suction between the silicone and the material, the rigid material that you applied onto it very tightly. So there's a lot of suction, and you're going to see some resistance the first time you remove the piece from the support shell. Now, before I actually go on to the mold itself, what I like to do is come back to the support shell and clean up some of those interior edges with a scraping tool or a knife. Just removing some of those sharp edges along the inside and possibly outside. Again, this is something that can cut you easily. They're sharp, thin edges. So I want to take care of those as soon as possible. And you're going to follow that all the way around the inside edge. You don't need to scrape up a lot, just a little bit to get rid of those sharp edges. Now, the reason why we have a sharp edge there is that some of that plasti paste made its way into that cut that we put in the separation key here. So that little cut we had, some of that material made it in there and now created a sharp edge on the inside. See that cut again? So that cut that followed in there, we pressed material right against the shims, and some of it, a little bit, made it inside, and that's what we're now scraping out of the support shell. Now just a quick test fit. Very nice. This fits perfectly together. And that's our support shell. Nice and lightweight, not heavy, easy to handle, nice and smooth, yet very strong and durable. All right, clean up a little bit around those keys. And now we can actually go ahead and set this aside. And now we're going to work on opening the actual mold. Again, I'm just going to clean my work area a little bit. Those clean work areas create clean castings and clean molds. Get some of this out of the way. Again, keep the questions coming, guys. If you have any questions on any of these steps, or even just on the materials that we're using, feel free to ask. We're here to help you. All right, so we have our rubber mold here. And we already made a decision that we're going to cut this mold open only on one side, going to the top. Now, a decision has to be made which side you're going to cut this mold open on. And it's somewhat of an easy and difficult decision. You have to think about what is going to be easier. Get this arm? Let's see. Is it going to be easier to get this arm here out of a uncut section, or is it going to be easier to get this arm out of the uncut section? So one of these sides is going to be completely intact, while the other one is going to be cut open. And to tell you the truth, I can't even remember which one I cut it on my previous mold, but I think cutting either side is better than cutting the mold all the way open. Let's see. I do have here some mold knives that I created. We can get a close-up shot on those, please. So these are mold knives that I made myself using razor blades. You can see there is a twist in them. And basically that creates a twisted cut, a cut with a channel. Here I have a mold knife that I purchased at a store. You can also see that that mold knife has also a groove, a channel, so that when you cut the rubber with that, it's going to leave that groove, helping two halves of the mold to fit perfectly together back in place, versus not having a groove. It'll be just two flats. So using a mold knife like this will align the two halves of the mold much better together. So now that we are ready, we can start cutting this open. A little bit of suction there. And I'm basically, sorry about the angle, but I think above head would be the best to see this. I'm simply going to start by cutting into the mold. You can see I found the previous groove where we cut on top here. And I'm just going to start by cutting right through that. Maybe a better knife would have been useful, but here we go. Now this is going to be somewhat time consuming because you want to go slowly. You don't want to just start cutting into it with no purpose. So go slowly and follow that separation line that we created. Parts of it I'm still going to cut with a regular razor blade.
Hey Milo,
Yes, sir.
do you know if Reynolds sells mold knives?
Who?
Reynolds.
Reynolds?
sells
Does
mold
Reynolds
knives.
sell mold knives? Reynolds is our distributor. You know, to tell you the truth, I'm not 100% sure that they do. While they do have a wide variety of sculpting tools, I'm not 100% sure that they have the mold knives available. However, if you guys want to make your own mold knife, you can do so. We did a video on that. You can check out our past videos that are available on YouTube. We show you how to make a mold knife yourself so that you don't have to buy them. They do get quite expensive. The one that I did purchase cost me about, I think it was $30. So instead of purchasing another one, I just ended up creating my own blades, basically.
They're kind of a pain to sharpen too,
Yes.
the mold knives.
There's quite a funny story about sharpening mold knives that I can't really get into, but in the back of my mind it lives. So yeah, I would suggest either buy them or make them yourself. A second set of hands would have been really useful here, but just like Batman, I work alone.
You want me to hold that open for you?
Yeah, I got it.
Okay. It's easier to cut when somebody is applying a little tension on that seam.
Right, somebody, you see I'm basically doing both of it. I'm putting some tension on the seam line and finishing cutting it as well. Can open that, spread it open as you go. Perfect. Good. Sorry, I'm not talking very much right now. I'm trying to focus on making a good cut here. But do feel free to ask questions, guys. I will answer them as they come in.
What about a zigzag cut versus using a mold knife with a channel in it? I think a zigzag takes up a lot of room.
Right, so Jason asked, what about using a zigzag cut instead of cutting a channel? And he made the point of the zigzag cut using a lot of room on your separation line. So can you do it? Yes. In that case, I wouldn't use a keyed knife. In that case, I just use the zigzag motion off the cut, and that becomes basically your key for the cut. Again, there's many different ways and methods that these things are achievable with. It really comes down to what you're learned, what you're comfortable with, and what you know how to do in a good way. I can tell you I'm not a great baker, but I still will bake cookies because they're really easy and I know how to do it. So we're almost done with the cutting here. And the reason why I want to show you the cut is I want to open the mold up to show you those separation shims that we put in. Those are going to be really interesting to see how those come open. Unlike myself, never cut towards yourself, always cut away. And almost there. We're reaching that reinforcement cloth, so I know we're right on the spot where we want to be. So that's good. Now we want to focus on the opening between the arm. And I'm going to slowly pull on that. So the rubber started to break, and it started to break where it was the thinnest, where it was touching that separation shim in there. I can slowly tug that and pull it. Until I'm able to retrieve that key that we built in there. Again, sorry about the visual here. It becomes very difficult to work on these tight areas, but I think we got it here. It's really important. Go slowly when you're opening your mold. You don't want to put unnecessarily rips and tears into the rubber. So rather work slowly. All right. All right, there's the first arm. There's our key out of it. That's our little shim that we made. You can see the keys on this side, the positives, and here are the negatives on this side. And now we're going to work our way down towards the leg area. Let's see how low. All right, and that came off much easier. Gloves for that. All right. All right, we got the area between the legs freed up as well. Let's see if we can get that key out of there. That shim. There it is. Or here's our second shim that was between the legs. And now the most difficult one will be on the opposite side. We can go ahead and peel the rest of the mold off. See, this is the beauty about having that shim that we put in there fit in just barely, just touching the model barely, because that rubber between the two halves is so thin that you can almost just break it by pulling on it slightly. And we don't mind that because we still have a nice clean separation line around that area. And there it is. We have our model retrieved. Let's see, we got those keys taken out. Very good. And here's our mold. So the way that the model fits in there, we're not going to have any seam lines on this casting on this side at all because the cut is only on this side of the mold.
Yeah,
so we eliminated working on that side to do any kind of post-finishing.
Yeah, somebody had posted and said, well, couldn't you do the same idea with a clay wall and divide the whole thing into two parts? You could,
yes,
but you'd have all that extra cleanup to do.
Right. So the question is, can we set up this model, the same model, and set it up in clay so there's clay between the legs, between the arms, and do a brush on over the entire thing, and then follow up by doing a brush up on the second side. And the possibility is there. However, what you're working with and fighting with is that you now have that whole nother side of a seam line to clean up in your casting. And depending on what kind of finish you're looking for on your casting, cleaning up those seam lines may or may not be desired or may not hide very well. So if I'm trying to do a cold casting with a cold cast finish, I most likely will do something like this where I don't have to cut open one side at all. That means I have way less post-finishing work to do on that piece. Now, we talked earlier about some material choices and why I would choose one material over the other. And you know, after I made this mold for you guys, I made all those models, all 11 of them. I decided that, you know what, that mold material I didn't really like, and the support shell material I didn't like, so I made a whole nother mold. This one is made out of Rebound 40. This is Rebound 40 rubber. And the support shell is made out of freeform air. So same approach, same techniques used, just different materials. I didn't even put any holes in these for bolting together because I wanted to use just rubber straps. And I went even a step further. What I discovered when I made the original mold is, you know, when I work on these, I'm going to have them upside down to pour into it. And I have to secure this now somehow so it stays in place. And I wasn't really enjoying that. So my next mold design that I did, I created these buttresses on the top of the mold. They're basically more material that was added, that was cured material that was added. And now what I can do is flip the whole thing upside down. And now my mold actually stands on its own. I don't have to jimmy rig anything around it to make it stand so I can work with the mold. It just sits. I can mix my material, get everything ready, boom, pour into the mold, start handling the mold, do whatever needs to be done. So a simple addition to the bottom here made my mold much more user-friendly, if you want to call it that. Will I do this on every mold? Absolutely not. But on specific molds that need a specific production, whatever it is, these kind of additions will be very helpful, and I will actually do them. And let's just go ahead and demold this piece because it's the same exact piece, just a different mold.
So, someone was asking which shell is lighter. And to be honest with you, because you're using more freeform air, they probably just about balance out. But applying the freeform air is different because you're putting it on like you would put clay on.
Right. The question is, which support shell is lighter? Is this one made out of freeform air or this one made out of the plastic paste lighter? And to tell you the truth, they're about the same weight. This one is applied a little bit thicker. This one is applied a little bit thinner. This material, freeform air, has a completely different consistency. And I'm going to just reveal a little bit about myself here. I love this material. I use it on a lot of different projects, and I actually prefer this over the plastic paste. But somebody told me to use the plastic paste, so I did. there's a lot of different choices for your support shell materials. And if I wanted to make this a lightweight, super lightweight, feather light mold, or rather support shell, I would do something like this. This is the Iron Man helmet that we made. There's actually a video. You can check this out in the links below. There's a video on this. But what I really like about this mold, look at this shell. This is really, really thin, very, very strong support shell, and it's very, very lightweight. I can toss this around no problem. Really time-consuming effort to make support shells like this. So the decision on which product to go with, it's really up on you. For some molds, this is the better way to go. For some molds, this is the way to go. For some molds, it's really up to you. What's your preference? What do you know how to work with? What do you enjoy working with? Like I said, I love the freeform air. I think it's like clay, consistency, and I really love working with it. So I will opt out for that. Also, there's a couple different versions of the freeform air. So I like that option about it. But it really comes down to you guys as far as which directions to go. Really quickly, I want to step back and go back to that one question we had earlier about placing keys in the middle of the mold so that it actually supports the piece from slumping inwards. So you can see here that on the helmet, the side here, I was really worried that this is going to be going in back and forth as I'm trying to work on the mold. So I put a key right in the middle of that, of the side of the head. You can see the keys on the front, the top, and they're actually embedded in the support shell with no separation line. There's no separation line here. Why is that? I wanted the mold to be really squishy and very maneuverable and movable in this area, so I didn't add additional material by adding the the cut or seam line. I just built a clay support here and worked off of that to make the support shell. Really good video. If you guys should have a couple minutes, go ahead and check it out. I'll show you a different way to make a support shell, but still using the Rebound 25 as our main molding rubber. Now, let's quickly go back to our statue here. I do want to open this up just to show you guys how nice these castings can come out of your molds by using the right techniques. And really what I'm looking for here, is minimal seam lines, and I'm looking for minimal seam lines in the open areas where we use those keys, or separation shims that we made out of the bubble sheet. I'm just going to peel my mold back. Oh, here's our casting coming out of pretty much the same mold. This is like the Rebound 25. It's just I opted out for something stiffer. This is Rebound 40. Not stiff enough, I guess. Same approach as far as the technique, what we did here. Same everything except the rubber that I used was stiffer and the support shell was different. What I want you to notice is these areas right here, there's hardly any flashing here. There's nothing really. You just have to scrape it lightly to clean off that separation line. Between the arms up top, same thing. It's a very clean area here. I don't have to do much post-finishing effort at all. And because one side was completely closed and we did not cut the side of the mold, that entire side doesn't need any cleaning after it's been demolded. Now on the bottom there's some flashing that we can simply break away. And we're ready to start our finishing efforts on this casting. Now when you if you consider this piece intermediate and somewhat advanced, when you start working with more difficult pieces that have multiple openings, I'm going to step out of the way so you guys can see that. There's multiple openings on this piece. There's behind the leg here, there's underneath the jacket back here, and this is open here as well with multiple deep crevices going way in there, way in there. So that becomes a very difficult piece to work with. And you have to give this a lot more thought as far as how you're going to go ahead and set this up to minimize any kind of seam lines that are going to come out of there, to minimize any kind of flashing that you have to clean off. And in this case, because it was a metal casting, I absolutely wanted to minimize any kind of cleanup efforts I'm going to have on the base, where there's a lot of texture, or on the side of the casting as well. So this mold itself was only cut from the top of the head to the bottom, and then there was some shims in the bottom here that helped with the demolding process. And same techniques, similar materials were used for the mold for this. Freeform air, I used the buttresses here, support buttresses, so I can easily set up my mold, and I can start working, pouring material and handling the mold. The major difference, I use different molding rubber. This is Dragon Skin 10, I believe. Much softer, because I was worried about the deep crevices and yanking on the rubber quite a bit. I was worried about possibly ripping it or damaging the piece. So I went with a softer rubber. The support shell itself is made out of 4 pieces with actually 2 plugs that are held in the main piece in the front. So you see a bolt here and a bolt here. Those are actually plugs inside that deal with the deep crevices on the inside of our mold. So another step of complexity that's added to a piece like that. But I use absolutely same procedures and same techniques and similar materials to go about making this piece. And I'm going to show you guys one more mold that we made here. Now this mold is a little bit larger and deals again with large areas that span across large spaces, and we need to hold the mold in place so that this large area doesn't just collapse inward and deform our casting. Same technique, similar materials are used. The support shell here is made out of freeform air. You can see here on the side, there's freeform air, and it's sandwiched between a layer of epoxy coat, I believe, and the top layer here is actually epoxamite with glass fibers built into them, creating a much stronger support shell. And then, because I was a little worried about the piece being so long, I actually worked in, you can see here, you see this groove, this bump. So there's a bump there and a bump here that continues all the way down the entire mold. That adds extra rigidity to the overall setup of the mold. And just so you guys can get a better idea of the size of these molds, this one has its own feet that it stands on, and it's actually a 3-part support shell. We have a front, we have a bottom, and we have a back piece. Same technique used, different materials. This is actually made using the MoldMax stroke, because the model that we used was made out of polyester epoxy. And the polyester would inhibit the cure of platinum silicone, so we opted out and made a brush-on mold using the MoldMax stroke. Again, same technique, keys used, separation channels and all that, but a different material, different application. So, I want to thank you all for watching this here today. Now let's just go over what we actually learned. We were talking about brush-on molds, and we wanted to show you how to make a choice between a brush-on mold or a pour-on mold, how to make that decision early on. Excuse me. We're also talked about making support shell materials and what options are out there, what kind of options are there for molds, and how to consider those options. We talked about considerations for making intermediate or advanced brush-on molds, because that's what I would consider that piece that we worked on. We talked about options on how to deal with pass-throughs, like open areas between legs and arms. We talked about using keys, separation channels, and we also talked about mechanical lock by avoiding any kind of undercuts and deep crevices in our model. And we also, of course, talked about the aluminum shims and how I use them to make my support shells. Now, the materials we used in this video was the Rebound 25. That's our main material we used for the brush-on mold. We also ended up using the Plasti Paste 2 for the support shell. Thivex was used for thickening of the silicones, and the Sonite wax was used as a separation tool for the support shell. Silk Pig was used for the coloration of our different layers. And one thing that I didn't touch up on is the Silpoxy. So before I let you guys go, I want to talk about one more thing real quick. So after you actually open up your molds and you start looking into them, and you're going to notice that maybe there's an air bubble trap somewhere, or that you actually went ahead and when you're cutting the channel, you cut sideways and there's a nice cut on the side of your mold somewhere. Now, how do you deal with something like that? And I want to show you guys exactly what I mean here. If we can zoom in here at the bottom, please. You see that? There's a little bubble in there that made its way into the mold. And that compresses easily from one side. So what you can do about issues like that is actually take some of our Silpoxy adhesive, and you can fill those holes by filling them with the adhesive itself. This is quite a thick product, so it will stay in the bubble itself quite well. And I want to actually just go ahead and open this and show you guys what I mean by that. This is a one-component product, so no mixing is necessary. You simply open the tube. We're going to puncture the tube here open. And then I'm going to squeeze out just a little bit onto a working tool. And now I'm going to fill that hole, that air bubble, with that silicone adhesive. There it is. Now, this is allowed to cure for at least an hour before closing the mold. You don't want to prematurely close the mold and actually adhere the two halves together. But I wanted to just quickly show you this because in your mold making adventures, you will encounter a mold that you either rip or cut and tear, and you do need to repair it. And this is a really easy way to do that. And you can actually also check out a video that we did on fixing ripped silicone molds by using the Silpoxy.
One interesting point about that is once you have a Silpoxy repair on there, you can't go over it with more platinum silicone.
Right.
The Silpoxy will inhibit the cure of, so don't use it to stick your keys on or anything like that if you're going to encapsulate them.
Jason made a really valid point here, is that you don't really want to use platinum silicone over the Silpoxy itself. So don't use it to adhere any of the keys to your molds. Use the actual material that you're working with, and use the Silpoxy purely as a adhesive for fixing broken silicone. You can adhere different silicones to each other with this, but again, don't apply other platinum silicone over the Silpoxy. That make sense? All right. Well, I wanted to thank you guys all for watching and participating today. And don't forget that our next event is on March 11th. We're going to do a live casting techniques with Alginate. My coworker John is going to be presenting that for you guys. And for future, we're going to be announcing our events on our social media, our email newsletter, and of course our YouTube channel. So don't forget to subscribe, sign up, or follow us, and of course leave us any ideas that you may have about what we should do next. And with that, I want to say thanks again, and see you guys soon. Ta-ta.